Hello, this video is titled the Improved Performance Research Integration Tool, Forces Modeling Overview. IMPRINT stands for the Improved Performance Research Integration Tool. It is a manpower, personnel, and training prediction tool owned by the U.S. Army Research Laboratory and developed by Alion Science and Technology. IMPRINT provides the means for estimating manpower, personnel, and training requirements and constraints for new weapon systems very early in the acquisition process. It is freely available to U.S. Department of Defense employees and contractors. IMPRINT contains 4 modules that each support different human performance analyses. In this video, I'm going to provide an introduction to the Forces module in IMPRINT. The Force module was designed to predict manpower and asset resources at a unit level. The model is built by defining the jobs and roles, assets and features, daily schedules, and unplanned events. An underlying model is generated based on the input data and executed using the Microsaint Sharp simulation engine. The reports are generated in Excel. Some example areas that the Forces module has been used for are predicting high-level joint service operations, evaluating force structure changes, seeing the impact of manpower allocation, and developing crew ship schedules. Some example questions to be answered are: can the available crew given the current resource inventory perform all the activities that are part of an emergency situation? What planned activities are interrupted? Is there enough crew and resources available to do all the emergency activities? What is the elapsed time for the planned and unplanned activities? What is the crew's quality of life in terms of personal time, routine duties, and consequence management related incident response work? From the IMPRINT Start page, you can load a recent model, start a new model, or load a library model. For this video, I'm going to load a library model. Let's go to IMPRINT. So here is IMPRINT. If I expand the IMPRINT library portion on the Start page, I get a list of all the library models included. The icons to the right indicate what types of models are in that analysis. The purple diagram shows that it's operation model. The tools show that it's a maintenance model. And the green people show that it's a forces model. I'm going to load the Bear Lake Fire Department analysis that has one force model. So if I go ahead and select that and just click on it, IMPRINT's going to open the model and automatically expand the tree view so that the Bear Lake Fire Department force unit is displayed. IMPRINT uses a fairly standard Windows application environment. You can see there is a title bar that shows the name of the analysis that's open, a menu bar, a toolbar, a descriptor window area, an output window, a message bar, and a properties window. The environment is user configurable. For a forces model, there are 2 main groups of elements that must be defined. The first is the activities performed. This includes both planned and unplanned activities. The second are the jobs and assets needed to perform the activities. We are going to review the parameters in a made-up force unit called the Bear Lake Fire Department. If you have IMPRINT, you can open up this library model and follow along. The first node under the analysis name in IMPRINT is the Warfighter node. This is used to define the agencies and specialties that will be modeled. IMPRINT includes a large library of specialties associated with the Army, Air Force, Navy, and Marine Corps. You can use these or define your own. Let's go back to IMPRINT and see what agencies and specialties are in the Bear Lake analysis. Okay, in IMPRINT, I can see that there's a Warfighters node. If I double click on that, it's going to open the windows where I can see selected specialties and agencies. If I click the Agencies tab, I can see the 4 built-in agencies, Army, Navy, Air Force, and Marine Corps, along with how many specialties are in each. And if I had any selected in my analysis, that would show here. I can see those are gray because you cannot edit or delete any of the built-in agencies. However, the fire department was added just for this model, so it's white. If I select that row, I can click the Edit Agency Specialties, and here I can define all the specialties in my analysis. I can give them a code, a description, and also an ASVAB compositor cutoff score. From here I can also add additional specialties or delete specialties. From the selected specialties list, I can see that I have 5 specialties selected, 1 from the default agency and 4 from the fire department. Down here, if I click the Select Specialties button, I'll get a list of all of the specialties in the Army by default. I can pick Navy, I can pick Air Force, I can pick Marine Corps, I can search for a certain specialty down here. To move a specialty into my selected specialty list, I just select it and hit the right arrow, and it becomes part of my selected specialties. That's how you define your agencies and select specialties for your analysis. A force unit is the top level for any forces analysis. A force unit is composed of personnel and equipment needed to fulfill a mission. It is composed of job roles, jobs, assets, asset features, and activities. For example, the Bear Lake Fire Department has jobs, assets, and activities. Force units are located below the Forces Models node in the analysis tree. So I'm going to go back to IMPRINT. Under the analysis tree, under the Force Models node, I can see the Bear Lake Fire Department Force Unit. I can click the little node next to Force Models and I can collapse it or I can expand it. If I wanted to add a new force unit, I simply right-click on that top node and select New Force Unit. IMPRINT will then create a new force unit and add it in the analysis tree. To specify the properties of a force unit, double-click on the node in the analysis tree. IMPRINT will open the unit description window. So here in IMPRINT, if I double-click on the Bear Lake Fire Department, a description window will open. Let's resize this so we can see everything there. The properties at the unit level are the name. Here we have Bear Lake Fire Department. The work schedules, the job roles, and the asset features. The name is just a text field where you can enter anything you want. The work schedules represent the different shifts in your model for both the personnel and assets. The Bear Lake Fire Department has 3 shifts named A, B, and C. Each shift is on for 2 days and then off for 4 days. To account for the on and off time, the duration for these shifts was set at 6 days. The remaining schedules are for the assets or equipment. For this analysis, we are assuming that each asset must undergo mandatory maintenance once every 20 days. So the duration for each of these assets was set at 20 days. Job roles are the methods by which jobs contribute to the force unit, or in other words, they are descriptions of the professional services or skills that may be required by the unit. There are the following job roles in this model: battalion chief, company officer, engineer, and firefighter or EMT. The asset features are the various pieces of equipment or features that are inherently either part of or carried by an asset and determine that asset's usefulness for addressing an activity. In this model, we have defined 9 asset features such as 4-wheel drive, hose, and ladder. If I expand the Bear Lake Fire Department node over here in the analysis tree, I can then see the activities, jobs, and assets. The activities are the next node in this. There are 2 types of activities in a force model: planned and unplanned. Planned activities are activities performed on a daily basis by the people or jobs in your model. These activities simulate a level of regular activity and availability of your jobs. Unplanned activities are activities which simulate a consequence that must be addressed and or managed. Since we're scheduling these activities on a scenario timeline in the model, they are not really unplanned, but you can think of them as events that are not normal occurrences and that can trigger additional activities that need to be performed. To view the planned and unplanned activities, expand the Activities node in the Analysis tree. Clicking the Activities node shows the planned and unplanned activities. I can see the individual planned activities by clicking the Planned node. You can see the activities are things like administrative, meals, chores, fitness, off-duty, personal time, sleep. If I double-click on any activity node, I can open its description window. So let's click on the Administrative node. And there's its description node. From here you can define the name of the activity. It's showing the unit name, but you can't edit it here. The sleep activity. If the activity is sleep related, then set the flag to true. Sleep activities cause a more recently rested crew member to be called on first. Then the last setting you can do is a priority. Here you enter a numeric value to indicate the activity's priority over others. A lower number means a higher priority. 1 is a higher priority than 5. Thus the higher priority one gets its resource needs met first. In this particular case, my administrative activity has a priority of 8. defined, the next step is to define the schedules. To view and edit the schedules, double-click on the Planned node. The Planned node is right below the Activities node in the analysis tree. If I double-click on that Planned node, it's going to open the schedules. And you'll notice there's a bunch of tabs across the top. There is one for each of the schedules that was defined at the force unit level. The first one shown here is 4WD, or four-wheel drive. Note that the time format goes day, hours, and minutes. So this particular asset, the 4WD, is available from 0 to day 3. It's down for maintenance from day 3 to day 4, and then is available again from day 4 to day 20. The last entry in the table corresponds to the end of the schedule duration, as specified in the work unit. In this case, it was 20 days. The next tab over is the A shift. This one is more complex. You can see that personnel on this schedule do a variety of tasks every day. The A shift is on a 6-day shift, 2 days on and then 4 days off. Thus, the off-duty schedule takes up the last 4 days. So if I scroll down here, I can see from day 2 to day 6 is off-duty. If I look at the B shift, so if I go over here and click that, all crew members are in the off-duty in the first 2 days when the A shift is on. So it's off-duty from day 0 to day 2. Similarly, the C shift, if I go click that one, all the crew members are off-duty from day 1 to day 4 when the A and shift B are on. Activities are added and moved using the buttons at the bottom of the window. There's an Add Activity button and a Remove Activity button. Now we are going to look at unplanned activities. Unplanned activities simulate a consequence that must be addressed and or managed. Things in a mission scenario that interrupt routine tasks. To view the unplanned activities, click on the plus sign next to the Unplanned node in the analysis tree. When I expand the Unplanned node under the Activities node, I can now see for this mission there have been 4 unplanned activities defined. If I double-click on any unplanned activity, I can see the defined parameters or edit them. Let's double-click on the Hazmat first activity, unplanned activity. From here is what I can define. The activity name, just a text field. In this case, it's called Hazmat-Tanker Rollover. A sleep activity, true or false. If the activity is sleep-related, set the flag to true. Sleep activities cause a more recently rested crew member to be called on first. This is not a sleep task, so let's leave it as false. The next field is a priority. Here we enter a numeric value to indicate the activity's priority over others. A lower number means a higher priority. For example, a 1 is a higher priority than a 5. This task has a relatively high priority of 3. The next field you see here is interrupt strategy. So here you can choose the strategy that indicates whether this unplanned activity must abort, resume, or restart if a higher priority activity pulls away its resources. And 2, the required resources once again become available for it to restart or resume. Here we're going to set it as restart. So the task has to be restarted when the assets are available again. The next area down here is job roles and asset features. For each role and feature listed, you need to enter the quantity which are both required and desired to address the unplanned activity. Note the desired value can never be less than the required value. The rollover event requires at least 1 company officer and engineer and 2 firefighters/EMTs. But if they're available, we would like to have more of these operators. We would like to have 1 battalion chief, and for the assets we require 1 hose, 1 medical kit, and 1 transport. But if available, we would also like a ladder. And that's it. So here in the middle here we have a where we have to tell IMPRINT what to do if we can add additional crew members. So we choose an option which best describes what happens to the duration of an unplanned activity if more resources or crew are added. The options are: it has no effect, additional crew members do not speed up the completion of the unplanned activity, it reduces time proportionally, each crew member added reduces the time the activity requires in proportion to the number of new crew members added, or reduces time somewhat. Each crew member added reduces the time the activity requires by some user fixed percentage. And finally, down here at the bottom is the activity timing. There are 5 different tabs that you can set for each unplanned activity. The first one is Start. The start time and day on which the unplanned activity is set to start. In this case, we're scheduling the rollover to happen at day 15 with a standard deviation of 2 days. The next tab is Duration. This is the amount of time that the activity lasts. The rollover response will take approximately 8 hours in this case. The next tab is Cancel. The cancellation time is an amount of time added to the model start time beyond which the unplanned activity is canceled if the required number of crew cannot be met. In this case, that nothing is defined. Let's go to the next tab, which is Repeat. Repeat is an interval of time past the most recent start of the activity at which the activity will repeat. Here, we set it at 30 days. This means that a rollover will happen on average once a month. The last tab is Stop Repeat. The stop repeat time is the amount of time added to the model start time beyond which an unplanned activity will not be scheduled if it is a repeating activity. We don't have anything here, so we didn't use this. So this data needs to be entered for any unplanned activity that's defined. You have seen that all activities added to the force unit model include a priority field. The values entered in these fields determines which activities will receive resources if there are only enough to cover some of the activity needs, rather than all. To see the priority of the activities, double-click on the Activities node. If I double-click the Activities node, I can see and edit all the priorities. The activity Off Duty is placed as highest priority so that crew members will get time off. Similarly, the Down for Maintenance is placed high. This is because the maintenance is deemed mandatory. The unplanned activities are next in highest priority, followed by all of the planned activities. So in this model, we can see we have priorities going from priority 0 to 25, and in the order of off-duty, down for maintenance, unplanned, and then planned. So far, we've defined our force unit and activities. We now need to define the jobs. Think of jobs as the individuals available who are distinguished by the types of functions they can perform within the unit. To view the jobs, click the plus sign next to the Jobs node. So that's down below Activities. So in this model, we have 4 jobs defined. Battalion Chief, he's the chief officer in charge of a battalion. He is qualified in all roles. The Engineer, this is the crew member who drives and maintains the engine. He is higher than a firefighter EMT, but is also qualified in that capacity. Next is the Firefighter EMT. All firefighters up to including the rank of captain are certified and start out as firefighter EMTs. The Officer is a company level officer in charge of a single engine company, station, or unit. A captain is higher than an engineer or a firefighter, but is also qualified in those capacities. We can double-click on any of these jobs to open the description window. If I double-click on Battalion Chief, his property window opens there. From here, I can enter a descriptive name, such as Battalion Chief. Select his specialty from the drop-down. Only those specialties selected using the Warfighter node are displayed. I can also select a rank. I can then specify the number available per shift. In this case, 1 chief is available for each shift, A, B, and C. Now we can specify what roles the chief can fill. He is the highest trained operator and can perform any role as indicated by checking all of the boxes. Now let's go look at the firefighter EMT by double-clicking. Now you'll see that this job is only qualified for the firefighter EMT role. But there are more of these available in each shift. The A shift, B shift, and C shift each have 6 available. Job roles are different from jobs in that they are services or skills required by an unplanned activity. However, both may share the same names. A single job or person available may be able to fill 1 job roles or several job roles required by an unplanned activity, depending on how the role is defined. But he or she can only fill 1 at a time. For example, the job company officer can fill the role of company officer, engineer, or firefighter/EMT, but not chief. We have one more element left to define, the assets used. An asset, which may be thought of in some industries as an apparatus, is the means or conveyance for bringing needed equipment, asset features, to the planned activity. To To view the assets, we expand the assets node in the analysis tree. So let's scroll down. There's our assets underneath jobs. If I click the plus sign there, I can see that we have 4 assets defined. I've got a 4WD, which is a vehicle equipped with a 4-wheel drive, an aerial ladder truck, which is an aerial ladder truck with a 100-foot aerial ladder, an ambulance, which is a vehicle equipped with medical supplies and can transport people, and finally I have an engine, which is a basic firefighting apparatus whose 3 major components are water tank, water pump, and firefighting hose, also known as a triple combination. I can double-click on any asset to open its description window. I will double-click on engine. So there we go, and there's its description window. From here, I can enter an asset name, so here's engine, specify how many are available for each shift, and specify what features it has. In this case, there is 1 engine available at station 11 and 1 engine available at station 2. Each engine has a chainsaw, hose, medical kit, Pulaski, water pump, and water tank. These properties are then set for each of the other assets. Just like jobs and job roles, an asset can fill multiple asset feature needs. For example, the ladder truck is the only asset with a ladder, but the ladder truck, engine, and ambulance all have medical kits. Depending on the asset feature required, the assets which are capable of meeting those requirements are called in. Now we have defined all the components in a force model and we're ready to execute the model and view reports. There are 3 steps that we recommend you do. The first is to check and set the execution settings, followed by checking for errors, and third, running the model. Open the execution settings window by clicking the checklist icon on the toolbar. Okay, from IMPRINT we're going to click this icon right here that says execution settings. From here we can specify what unit we want to run. We're going to pick the Bear Lake Fire Department. We say the length of run, we're going to go ahead and run it for 90 days or 3 months roughly. We're going to set the random number seed, and we can select a fatigue model if multiple ones are installed. In this case we only have 1. So that's what we do from execution settings. Then to check the model for errors, we just simply check this little check mark on the toolbar. It's going to check the model and report any errors in the output window. In this case I've got no errors found. Note, the model must contain at least 1 schedule, 1 activity in that schedule, and 1 job, or you're going to get an error in the output window. So now that we've looked at our execution settings and we've checked our model for any errors, we're ready to run the model. So now you just need to click the little play button on the toolbar. So let's do that. And as it's running, we can see the clock update down here, and we can see simulation complete in the output window. When you're running your force unit model, the simulation engine simulates the baseline utilization of all jobs and assets and various activities according to the schedules you have defined. In parallel, it also simulates the unplanned activities you have defined, which are designed to disrupt this ongoing schedule, and the data generated from this overall simulation predicts a realistic performance by your force unit in its effectiveness to address those unplanned activities over the length of time specified in the execution settings window. So the output window indicates when the model is complete. It ran for 90 days and took, in real time, about 3 seconds, almost 4 seconds. Now we are ready to look at reports. IMPRINT Pro provides several different reports for viewing the force unit data. Report presentations include tabular report and chart reports. Let's go back to our model and look at the reports. So now that we've run our model, let's go look at the reports. So under the Reports menu, select Forces Results. This will bring up the report selection window. There are 10 reports to choose from. Let's look at all the reports by clicking the Check All button down at the bottom. It's going to check all of the available reports. Then we're going to go ahead and click OK to tell IMPRINT to generate the selected reports. Status is shown down here in the message bar. IMPRINT may ask for details on what assets or jobs to include, but by default all are included. Once the reports are generated, Excel will open with the selected reports. Each report is shown in its own worksheet and accessed using the tabs at the bottom of Excel. The name of the report, activity data in this case, and the IMPRINT logo are shown at the top. Data about your model run appear right below that, and then the actual data shows in the middle of the worksheet. Our first report is activity data. We use this report to see what activities happened and when. From this report you can see right away at time 0 the first unplanned activity happened, the medical single motor vehicle. Scrolling down, we can look and see that the B shift people were off duty, the A shift were sleeping, etc., etc. We can scroll all the way down as the model run for all 90 days. The next report is time total by individual resource. This report displays the number of hours a resource contributed to each activity. You can see for each resource, job and asset, what schedule they were on, what activities they participated in, and the total hours per activity. The crew effects on duration report shows the impact of adding additional crew over the minimum required. You can see that the minimum 4 jobs was met for each instance. However, only 10 out of the desired 11 were available. Adding additional crew had no effect, and therefore no impact was defined. The unplanned activity status shows the unplanned activity status over the simulation run. The status can be scheduled, started, delayed, interrupted, successful, or failed. At time 0, the structure fire was delayed due to the unavailability of the battalion chief. At time 15, so if I scroll down here to time 15, I can see that structure fire resulted in a failure because it reached the cancellation time. The next one, the unplanned activity status summary, shows for each unplanned activity how many were scheduled, started, successful, interrupted, delayed, or failed. Failed activities indicate a shortage of resources. So in our case, our medical single motor vehicle unplanned activity failed 5 times, and our structure fires failed 2 apiece for type A and type B. The unplanned activity required versus met is similar to the crew effects on duration report. We can see how many job roles and assets features were requested and met for each activity. Amounts, however, are broken down by resource. The unplanned activity resource participants report shows each individual tagged resource used for each unplanned activity. Each individual is tracked by a number in brackets following the name. So here I can see my battalion chief, number 1, fulfilled the role of an engineer. If I scroll down here, I can see he filled the role of a company officer. The unplanned specialty usage report reflects the usage of each specialty in the model, total man hours over the 90 days. A separate activity time for resource chart is generated for every resource chosen in the selection diagram. The tab is named Time, followed by the resource name. For WD, the asset was available for the majority of the simulation. If I scroll down here, the asset was available. For the battalion chief, so if I go here, scroll down, most of the time he was working on the hazmat tanker rollover, 3 of them. The total time by resource shows the time that each type of resource spent on each activity throughout the entire run. And then a separate activity time by schedule is generated for every schedule. This tab is named Time, followed by the schedule name. So this schedule is a 4WD. If I go to the schedule A, I can go down and see how much time was spent on each activity. The total time by schedule shows a tabular version of the activity times by schedule. One interesting thing in this report is that Engine 2 spent nearly twice as long in the activity called maintenance as the Station 11 engine. So if we scroll down and see, here's our Station 11 engine, our Station 2. This one spent 96 hours down for maintenance, and Station 11 engine only 45. So that's all of the reports that are generated. During the simulation, the model assesses all unplanned activities which have fired. It then takes into account the resources, jobs, and roles available within the unit, the activity schedules of those resources, and the manning requirements of the unplanned activities to determine whether or not the unplanned activities may be addressed. By assessing the crew's ability to respond to the unplanned activities, the model demonstrates the feasibility of the manpower and equipment estimates currently assigned to the force unit. These assessment data are presented in the form of reports. Thank you very much for your time viewing this video. My email information is shown on this slide. Please contact me with any questions. If you do not already have IMPRINT, you can request the software using the incredibly long email listed at the bottom of this slide. Happy Forces Modeling!
Remember, the Force will be with you.